Hey everyone, it's Harriet, and today I'm going to be showing you a tutorial on how to use NX drafting. So we're going to start with the basics and learn how to navigate to NX drafting, choosing the correct sizes, importing title blocks, going over drafting preferences, changing views, adding dimensions, and going over standard notation for holes. So this tutorial is going to be a little bit different in that I am featuring a lot of different ISS members who will be helping us learn about all these drafting features. So I hope you enjoy. So first up we have Jamie, who is going to show us how we go about getting into the drafting environment.
Hey guys, my name is Jamie and I'm going to show you how to go from designing a part to going into the drafting environment. First, if you had just created a solid model or an assembly, make sure you save it so your draft uses the most up-to-date version of that model or assembly. So go ahead and save. And then next, to get into the drafting environment, you're going to go File, New. And so when you're in New, first thing you want to make sure is that you're in the Drawing tab. A lot of times when you pull up New, it's in the Model tab, but we want to be in the Drawing tab right now. So after you make sure you're in the Drawing tab, you're going to go down here and change your units. It's going to be the most advantageous to you to use the same units that you created your solid model in. Next, you're going to change your sheet size. I'm going to stick with A0 for now. It just depends on what sheet size you want to use. Same thing as creating a model. You're going to go down here and you're going to change the name and the location of where you want it to be saved and how you want it to be saved. And next is, since I'm opening up the drafting environment with a part open in this window, it assumes that I want to use that part in my drafting environment. If you don't, if it picks the wrong part or you have multiple parts up on in your window and this is not the right part, you can click this little button over here and search for a new part, either by the ones that are open right now, or you can click here and you can search your computer for whichever part you want. But I'm perfectly fine with the one at once. So if you change it, you just press OK, but I'm fine with the one that is already opening. So I'm going to just press cancel. So after you change your units, your sheet size, name and folder, you go ahead and press OK. And now you are in the drafting environment. But to get to the drafting environment from the welcome page, so you just opened NX and now you are in the welcome page. You're going to go same process. You're going to press new. Again, make sure you're in the drawing tab to get to the drafting environment. Change your units to what you want, either millimeters or inches. Your sheet size again, your name and your folder. And since you're opening it up from the welcome page from a brand new window of NX, you can't really choose a part right now, but a later video will show you how to insert a part that you want to draft. So again, drawing, change your units, change your sheet size, update the name and folder, hit OK, and again, you are now in the drafting environment.
Now Jamie will talk about setting up our drafting preferences.
Hey guys, my name is Jamie and I'm going to go over some drafting preferences that are good practice. So once you're in the drafting environment, you're going to head over to File, Preferences, Drafting, and open that up. So first thing we're going to change is we're going to, under Comment, we're going to expand the line arrow, and we're going to head down to Arrow Line. Scroll down to the bottom to vertical alignment and change this box to leader from middle. Next, go ahead and go down a level to extension line and make sure that this box is checked. Apply to entire dimension, should have a check next to it. We're going to change gap to 1, and same thing with side 2, that gap should also be 1. Next, we're going down to drawing view. We're going to expand that, and then we're going to expand common. So under drawing view, under common, we're going to open up smooth edges, and we're going to uncheck that box. So the box next to show smooth edges should be empty. Next, we're going to go up to dimension and expand dimension. And then we're going to open up dimension set. So in dimension set, change should be 0, and we're going to change the baseline to 8.0. Next, we're going to go to dimension line, and we're going to turn off line between arrows, and we're going to turn on trim dimension line. So the box next to line between arrows should be blank, and the box next to trim dimension line should have a check. Next, we are going to open up text and then open up units. So for this decimal places, if you're using metric, this should be 1. If you're using standard, then you should have 3 decimal places. So this should be 3 if you're using standard, 1 if you're using metric. And then down here, we're going to change from comma to period. And then these 2 boxes, we're going to turn off show leading zeros, and we're going to turn on show trailing zeros. So this box should be empty, and this box should have a check. Next, we're going to go to orientation and location. The only thing we're changing here is this drop-down menu, and we're changing this to horizontal text. Finally, we're going back down to drawing view, and then back under common, and then we're looking for hidden lines. So open up hidden lines, and we are going to change from invisible to dashed. And that is it. Those are, so after you have gone through and changed all these preferences, go ahead and click OK or apply, and everything should be updated. And then you are set to start dimensioning.
Kenneth will show us how to choose the correct settings for a new draft and how to import a title block.
Alright, so I'm going to show you how to import a title block and change the sheet sizes. So here we have different templates that you could use. So depending on what paper you want to print on, you could print on A3, A0. Usually A4 is kind of like that US letter size, so you can use that. You can also use standard sizes. So you have you could just use a blank piece of paper. You can also change the size to custom depending on what kind of paper you want to print on. You can also select what inches you use and the kind of the projection style based on what standard you're using. But for now, we're going to use a template, and we're going to use the A4 size, and this will allow us to import a proper title block for us. So I'm going to hit OK. So it's going to prompt us to populate our title blocks, but we're going to hold off on that real quick, and we're going to import our parts. So I'm just going to scale this down a little bit and hit close. Okay, so we have this part. But now, say you draw this and you you want to mark down when you drew this. This would be kind of how you would have proper verification of your parts. So let's say that this was first drawn today. I would note our date, which is March 31st, 2021. And, oh, did I mean to exit out? And then I'll say that this was drawn by me. Now, say this part is checked by someone else, then the person that checked it out or approves it can write their name, person A or person B. And as you can see, as you fill that populated title block, it'll automatically populate within your within the imported title block as well.
Both Noah and Ronnie will be discussing how to do the different views on our model.
Alright, so my name is Noah and I'm here to show you how to do the different base view and model views when drafting. So now that you got your drafting page up, you can go over to the home banner and click on this base view up in the top left. This pulls out your base view window, and this is where you get to choose your placement, the different like angle or side you want to show, and scale in case you want it's too small page. Then you can just hover over to the right and you get to choose and just click wherever you want to place the different view at. And so ours is a little small, so we're going to increase it a bit. And also the top view is kind of your standard to start with. You can do we typically want 3 different faces of your model, so like top, front, side, and we'll get all 3 of those in here. So you can just start with the top, click on that, this top left quadrant, and then it immediately pulls you into this projected view page and window. And here it pulls up and you can add more views. So here we'll add this side view into this lower left quadrant. And then we can also add the front view into this top right. But say you accidentally close out of that, there's no worries. You can go right back up to this top left and see this projected view button. Click on that and it brings that page right back up and you can throw that in. Then you can close out of that and you're good. You can also throw in a detailed view. This lets you like zoom in on certain parts. So if I want to like zoom in on that like feature of the rover body where the whole like cables went through the body, I can like kind of zoom in and select how like much I want to zoom in, what all I want to be included in that detailed view, and then click again, and then it brings up this extra page where I can throw in that detailed zoom, and I'll just throw it here in the middle, and that brings up that detailed where we can put in more precise and like smaller measurements and dimensions. You can also do detailed views in rectangles. And then as well, a lot of times people will also want a like non-dimensioned, a isometric view, just to kind of understand the look in 3 dimensions of the piece. So you can just throw that in, going back to base view, and just changing it to isometric instead of top. And again, changing my scale so it matches. And you can just throw that in the bottom right. And then close out of that. And there you go. You're all ready for your dimensions.
Hi everyone! Now that we have our model, and we've switched to the drafting mode, and maybe even filled in a title block, we're ready to start placing down some drafting views of our model. For this tutorial, I've made a simple block I model, which has different views for every feature that we look at. So we'll begin placing our drafting views by clicking Add Base View at the top left corner in the main ribbon. From these drop-down menus, we can choose the initial view that we are going to place down, or the size of the model on our sheet from the Scale drop-down menu. For this tutorial, we'll put down the top view first on the top left corner using a 1:2 scale. So once we choose those 2 settings, we can click anywhere on this sheet to place it down. So I hover over the sheet and I chose where I want to place the top view and I clicked. Now it's printed on the page with its coordinate axis. So now we have multiple options for placing other views. we can escape out and manually place another view using the same exact method. So we will place down the right view right underneath using a 1:2 scale. And we can do that with other views as well. Or we can let NX manually infer where we want to place the other views. So we'll go back and place down another top view. And now we can hover around the sheet and NX will automatically place another view. This way, the views are automatically aligned with the other ones that are already printed on the sheet. So first I place the top view, and now I'll place a side view underneath it. And I can also place a diagonal view. And you can see that they are all perfectly aligned with each other. With this automatic placement method, you can see that all the views can be manipulated together, all while maintaining alignment. Now instead, I'll go back to placing the views manually. Now instead, I will manually place down a top view and exit out, a back view and align them, a front view, which looks very similar, and I will also place down an isometric view over here. Notice that this way, when you move the views around, you can still have them line up with each other, but they will not all be manipulated and maintain alignment at the same time. From here, you can continue the drafting process, and you can also put constraints directly onto these drawings that you've placed down, and you can continue to move them around and change what is showing up throughout the entire process.
Now, Andrew Larkey is going to be giving us an amazing rundown of doing dimensions.
Hey everyone, I'm Andrew. I'm one of the team leads for the hybrid rocket engine project working with the IREC team at ISS. And I'm going to give a quick tutorial on dimensioning for drafting, specifically on NX. So here I have a quick little widget I made. It's a rectangle, 3 holes down the center. One of the corners is cut off on an angle. So if you move to drafting, you can see I already got a head start, kind of like they do on cooking shows. So I already have my views put down, and this is just a top view, this is a side view, and then this is an isometric view. So when you're drafting, or really just when you're drafting, the most important thing is to be aware of who your audience is. And your audience is the machinist or whoever is in charge of manufacturing this part. So the most important thing to keep in mind is to make it as easy as possible for your machinists, who also are excellent resources for asking questions, especially as engineering students. They've seen tons and tons of practical hardware, and they're probably better engineers than all of us are. Obviously, they're probably not as good at determining like heat transfer or whatever, but as far as practical manufacturing and how things interface, they're excellent resources, and they've been a huge help in my past on projects. Anyway, with that in mind, one of the important things to try to, one to try to do to help them out is to have all your dimensions in inches, which sucks because having them in meters or SI units or whatever, much better. They're just much easier to use as engineers. But machinists only think in inches, at least here in the US. If you give them something in SI units, if they're mean, they might give it back to you and tell you to change it. If they're nice, they're just going to watch them like write on it and change all the units from SI units to inches, which kind of sucks because it's harder on them. And you want it to be as easy for them to get right as possible. So you don't want them to have to convert in their heads or whatever. With that, we can get started. So NX is pretty cool here. You can see that for these bolt holes, they've already added your center mark. So I'm actually just going to delete that real quick just so I can show you how to do that in the future. But to start, we're going to start with the easiest dimension, which would be the width of your rectangular prism, whatever it's called, on this this view right here. So over here you have your dimensioning tool. So you have linear, radial, and angular. That's pretty straightforward. You also have a rapid tool, which NX uses its computer science to figure out what sort of dimension you want. It doesn't do a great job of picking up on radial or angular, but it does figure out what type of linear dimension you want. So if you're doing anything like that, which I'll show you in a sec, it's super easy and kind of fun to use, I guess. So we're going to start with the rapid. It's going to take a second to load. So you're going to get this little pop-up window. So most of the pop-up windows will look something like this. You can just zoom in exactly on the view that we want. So select first object, select the second object. So an object in this case is going to be, and it's going to be highlighted, a line, a drafting line. It could be like a vertex, something like that. So in this case, we want this width, which would be the distance from here to here. And there are two ways you can do that. So one, because this is the rapid dimension, we'll just figure it out real quick. You can just click one and it'll do the dimension for you. So you can move it up and down any way you want. You can move it left, right. Here it's pretty simple. There's not a lot around it. We can put it wherever we want. So you click to put it in place, and then you can do a bunch more. On this part, we don't need to do more. So I'm just going to close out of this. And then we'll come back in a second and kind of fix all of our dimensions. So the way I like to do it is to go through the view and just get all your dimensions down. So just click through everything and then kind of edit them and put them in place as like your second step. So that one was kind of quick just because this view over here is where we're going to do most of the work. So we're going to start again with the rapid dimension. This on this side here. So we're going to now do the width, which we can easily click and just put in place. And I'll show you what that little thing popping in this area was in a second. You'll probably see it pop up, but we're going to deal with that later. Oh, I forgot to place it down, so don't do what I just did. We'll start again. Place it down. It's not being annoying. Okay, and now it's ready for the next object, which in this case, actually, we're gonna just start there. Oh, what the hell? Oh, teensy curse. Let's just do it this way. So select the first object, the second object will be here, and we'll place it there. Okay, so if you're ever having trouble with the rapid dimension, just use the linear dimension. I don't know why the rapid would be an issue, but that's okay. Okay, so now we're going to hit our circular center marks. And there's a cool tool for that. And this was the thing that was auto placed when we opened this draft view up. So over here, this drop-down list is all a bunch of different notations. So we're going to use the center mark, but in the future, you can end up using this bolt circular center line. So if you have like a big flange and all the bolts are on, like the center of the bolts are all in one circle, which you can kind of see from the little picture there. It'll like highlight or make a dashed line connecting all of them. In this case, we're just going to use this part, which is the center mark, and it places just a little X marks the spot at the center of your holes. And if you have multiple and they're on the exact same line, it'll connect them all. And this will make it easy because when you have to make dimensions to place the location of this circle, you just need one, because this lets you know that they're all, like, the dimension from this side to this side will be the same for all of them because they're on the same line. So we can just do that. We hit OK. From there, as I just mentioned, let's add the dimension from this side to the center line. So what we can do a linear, because it's linear, pick this, and then it's kind of a lot of stuff overlaying, and NX gets a little slow, but there we go. And we're going to move this on this side over here. Okay, so we're going to keep doing that, this time in the vertical Y direction. So you can select the bottom here, select that guy, and that's rotated. And I'll show you how to fix that in a second. And then there are a couple ways we can do the second one. You can either choose to have the dimension based off of the location of the second hole, which is how I'll do it here. And if you put them in line, they'll kind of line up, which is nice. Or maybe it didn't there, I'll fix that. And we can just do that one more time. Okay, there we go. And then, of course, you also want the length of this rectangle. So there. Oh. From here to all the way to the top. And we will put that on the outside over here. Okay, so finally, we have this angled section here. And here's where you bring out your angular tool. First object is this line, second object here, and then you can just pull it. So you can change the different direction you want. So if I pulled over here, it's 145 because it'll use that from that relative angle. Or you can pull into the center and it'll use the 35, which is what we're going to do. Okay. So now you have a fully dimensioned part, but you're not done yet because this looks really not easy to read. And as I said, making stuff easy to read for your audience is the most important part. We're also going to talk about tolerancing. So tolerancing is super important because, like, let's say this is 20, or in this case, it's 20 inches. The machinist needs to understand, because they're not perfect, they need to understand how much they can be off by and have the part still work. So let's say this part has to fit within, I don't know, like 20.1 inches. So it interfaces with a slot that's made to fit just around it. So it needs to have a tolerance for this dimension that says that it needs to be less than that value, which I can't even remember what I just said, 20.01 or something. So in that case, you'd want it to be 20, the tolerance to be 20, which you already have as the main dimension, but the tolerance of plus or minus 0.01, because it can be a little bit less. And there are also lots of ways of adjusting that even more so. So if you double click on a dimension, it'll bring up the full details, which you can use for adjusting small things. But you also have this. So this little window here is what it helps you adjust the actual representation of the part. So there are a couple things here. So this shows like the actual type of linear dimension you're using, which you can change. So here we're just using like a perpendicular point to point from side to side, but you can specifically specify a horizontal, which would be more useful if you had something with like weird angles and you wanted to like connect two different things. So this is how you set your tolerance. So there are lots of different ways of displaying your tolerance. The plus minus is just used the most often, and it's easy to read and easy to understand. Technically, you can have a plus and minus, and you can set different values for each one if you want to get really fancy, but we don't need to do that. And then you see the extra value pop up. And then here you can set the actual, how the text is oriented. So here the text is pretty much fine. Sometimes I like using this one because it sets in the center, but here it's kind of big, so it's just easier to put it on top, which we had before, which would be this guy right here. And then you can just, so you can edit that value. You can make this 1, but we don't want to do that. So it's also, tolerances are also important because not only do they need to be well tolerant so that your parts fit together, but they will also dictate how much time a machinist spends on the part. So the cost of a part is just based on, they have an hourly charge, and you might give them a part and they'll say this is going to take 5 hours and we charge you this much. But if you have tolerances that are really small, they're going to have to spend more time on it. So small tolerances will also drive up the part. A tolerance of 0.005 or 5/1000ths of an inch is considered pretty standard for most engineering parts. If you don't give them a tolerance, this is basically what they would just use for their own personal quality, I guess. If you have a reason to go smaller, you can feel free to go smaller. And it's also great, this is something that's great to ask machinists about because they've dealt with this stuff tons of times. You can also add other notes in this section. So this box is top, this is to the left, this is to the right, this to the bottom. So you can add any note, so like note. Yeah, that's useful in some very specific scenarios. And this drop down here is your number of decimal places. Since it's 20.0, they don't include the zeros at the end, so it's not showing up, so it doesn't matter. Of course, you want that to be in place. So I just moved it. It's kind of finicky. Brings up a good point though. So I'm going to close this. When you're placing your dimensions, make sure to never put them within the part itself. It's, I guess it's just for readability, but it's kind of just how drafting works. You'll look like you don't know what you're doing if you do that. And you want to look like you know what you're doing, which is, I assume, why you're watching this. Anyway, this is pretty much fine. We'll just move this up a little bit. Yeah, be careful with your clicking. I like to click everywhere, and NX likes to use that to figure out where things belong. So having the number outside is okay. Having the arrows inside is okay because they're specifically pointing to what it's being referred to. So in here we can click this, double click, get the details in here. This. So since we want it to be more readable, we're going to change it to something like that. You can do that here as well. And then you can also drag the numbers so it'll be more centered. I don't know. I thought they would click together. They're not. But as far as the 10 being vertically centered, there is a little click into place feature, which is convenient. And we'll do the same thing here. Of course, you still want to add tolerances for these parts. Move this to center. I'm not going to go through that because this is a widget and it doesn't matter, and you know how to set a tolerance from this. And now you know how to orientate things, add angles, add circles. Yeah, so that is the basics of how to dimension a part. It's important also to not over-constrain a part. If you add too many dimensions, it'll be harder for the machinist to read. And an important thing is to also consider how machinists are manufacturing this. So like what they do first, right? So machinists traditionally are working with subtractive machining. And if you haven't heard that term, you've definitely heard of additive manufacturing, like 3D printers where they build layers on top of each other. In subtractive, what they do is they start with a brick and then they keep cutting stuff out. So in this part itself, this would be a brick, right? And then they're going to start with the outside. So it's a 20 by 40 by 5, right? So they're going to cut out the top section, the left section, and the other 3D side until you have a 20 by 40 by 5. And then from there, you might cut out the like the bottom circle, the middle circle, and the top circle, right? But as I talked about tolerancing before, so let's say you cut out this circle, right? So the location of this circle is 10 inches from the left side, 10 inches from the bottom. Okay, so let's say you accidentally make that like, this is just ignoring what a reasonable tolerance would be, but if you were to make that accidentally 10.5, you could say, fine, that's close enough, whatever. But the way we dimensioned this second circle is we're saying this second circle is 10 inches from the first circle. So if they mistolerance this again, or I guess within your tolerance, but machine it again, technically make it 10.5, now this location is going to be 21 inches from the bottom instead of what you expected, which would be 20. So as they keep machining things based on other parts, if you don't tolerance correctly, you can have a big effect there. And that's why, so what this type of drafting, which is kind of simple, but it's used throughout the world or whatever, but this is how most of our parts in ISS are dimensioned, and how the machine shops can take it. So this is mostly what you need to know. But if you ever want to get more into this, there's a different type of dimensioning called geometric dimensioning and tolerancing. And that is used to take care of any issues that come from machining parts based on its location from another part. And it allows you to define what priorities you have. So you don't really need to know that. If you're ever taking a CAD design class, they probably won't teach you that. They should, though. It's used in industry. In your class, they'll probably mention it, I would think, at least. But just for a quick view, this is an example of a rectangle with more circles that has been done in GD&T, as it's called. So as you might see, there are similar types of dimensions, but then there's also all these other symbols which might seem foreign to you. And some of these, I actually don't even know what some of these are. But the important things here are these notions of A, B, C, and D. And these are kind of the driving aspects of GD&T. So it allows you to define a priority on like what part is kind of the base face or component. So in this, this is top view and this is the side view. So they're saying that on the side view, this face is going to be A, and that's your main face. In that case, that's actually just the face here. And then within this, they've defined B to be this angle, this side here, C to be this side here, and D D, I don't know enough about G, D, and T, but G is either the center or the outside ring of this circle here. And this allows you to define it based upon those datums. I've had to do this for an internship a few years back because most high quality parts need to have this more specific dimensioning feature, but that's okay. Rectangular dimensioning works. It's simple, and now you know how to do it. So if you have any questions, you can find me on Slack. My name is Andrew Larkey, and good luck with your drafting in the future.
Noah will introduce text editing.
Alright, so it's Noah again, and I'm here to show you how to edit all of your text now that you have your dimensions in. So I quickly threw in some linear and radial dimensions onto our Morty body. And so to start out, we can just click up here. You just double click on the dimension. It will pull up these two windows. The left window is your linear dimension. So this actually will alter your dimension. The text window is this window right here, this smaller one, and you have some basic options where you can choose how it measures. You can choose your tolerance. You can inspect your dimension. That we don't really worry about any of those three. The main one we will kind of worry about is like this button right here called text over dimension line. This kind of chooses where your text goes. Seeing how this is already horizontal, it doesn't make a big difference, but typically we want horizontal text is just the go-to, so I will show that later. But here on these windows, we can just type in different things. So it goes on top. You can type something on top. You can type something to the left, to the right, and below. So we'll say this is just like the Arduino slot. This is where the Arduino went into the Morty body, and we can say this is the length here, and then we can just exit out of that, and it prints it out up on top, and you can see how it prints it above and to the left. And so here we'll click on this one, and I'll show you how, since it's vertical, the number is kind of, you don't want to read the number like vertically, so you can switch it over to horizontal text, and it flips that text. Now it's beautiful to look at. And what we can do our Arduino slot again, and we can say this is the width, and we'll do it below to show the different views, and exit out, and now we got Arduino slot and width shown there. And then here again, you can also choose horizontal and exit out of that. And here we'll also quickly throw it to horizontal. And the next thing to show is if you right click, you can go into settings. This is your text settings, this one right here. If you click on that, and then this window pops up, if you go down to text itself, this pulls up. You can change your units. This is in inches, and so it'll say you can choose how you want it displayed, whether fractions or decimals, and then what decimal place is, and how far you want it to go. We mainly worry about your orientation and then dimension text. So orientation, again, this is where you get to choose horizontal or whatnot, and then I will show this on the radial dimensions because it actually plays a factor whether or not you do text above or after. So if we go down to dimension text, here is where it really matters. And this is where we can change the font. You can change it to whatever. We can just quickly, I'll just throw it on Berlin Sans, why not? And then this is where we can increase the font, and we can say make it like 5, and that'll increase the height to where that's a lot easier to read. And then you can just close out of that, and boom, that's done. And so for going down to these two radial, you'll typically want to, again, do horizontal and see how it kind of makes that angle onto the two dimensions. This is what uh, that orientation, that position. So this is text after the stub. If we change it to text above stub, it then increases the line and puts the text above the line. That is what that is talking about. And again, we can change the font to something and increase the size. And here we can also, while here, if you know the shortcuts to the different symbols, you can just type them in. If not, you can always click on this Edit Appended Text tab, and this window pops up. And here, it has a whole page that you can click down, and it has all of their basic symbols that you can choose. This, you can change the font and size of what you type in front of or below. And this is where you, up at the top, you can change to before, after, above, below. So we'll say above, and we can do, so we'll say this is countersunk, and we'll say it's countersunk 0.05 inches. And we can hit enter and see how it's now really small. We can increase that up to get it close enough. I did make that font a little big. And now we get that countersunk symbol 0.05 of an inch. And yeah, that's it.
For the final feature of our tutorial, Jake will discuss standard notation for dimensioning holes.
So for this part of the tutorial, we'll be going over how to dimension the holes in our drawings. So for this part, I have a box with a bunch of different holes in it. So we have a countersunk hole, a blind hole, a through hole, and a counterbored hole. So in order to create the flags necessary to describe these holes, we can use the hole and thread callout function in the dimension area. So if you pull that up, you'll get this little pop-up, and then you can just select the holes and then place the information tags. So you can just select each different hole, and you'll get a different type of call out depending on what type of hole it is, and it'll have different types of information. You can also, instead of applying the flags directly to like the visible lines, you can actually select the hidden lines as well and create flags pointing to these. So then once you have that done, you'll have all these flags. If you want to know more about like what's inside of them, or if you want to kind of change what information is selected, you can right click on the flag and then click settings, and you'll get this dialog. So in the whole callout section, you have all these different parameters that you can select and deselect, and they have different, they contain all the different parameters describing the hole. So you can see first it displays the diameter of like this section of counterbore, then it has the depth of it, then it says that there's a line break, so it goes to the second line, and then here we see like the counterbore flag telling us explicitly it's a counterbore, and then we get the counterbore diameter, and then the counterbore depth. And it'll be exactly the same for all the other ones. Same process, but you'll get slightly different parameters depending on which type of hole it is. But with that, now you know how to dimension all the different holes in drafting mode.
We're now at the end of the tutorial. I hope that this video helped you guys remember or learn some tips for drafting in NX. Thank you so much for watching.